All right, guys, it's time for our next speaker. So please join me in welcoming Olle Segerdahl.
Thank you guys. Yeah, my name is Olle. I work as a consultant, hacking stuff by day, and sometimes at least every other week I help make a Swedish language podcast about security stuff. So if you're interested in that, go find SecurityFest on your favorite podcast app. So if there's one thing you take away from today, I want it to be that F-Secure is not an antivirus. But let's get into it. So I'm going to show you some stuff about hacking, or how to go about hacking client-server systems. This sounds very old school, very 90s. The thing is, they're still around. Sometimes you find something where there's communication going on, and it's some weird binary protocol. It's not a simple REST interface that you can use Perf or whatever to get into. So this is kind of giving you some ideas about how to go about solving that problem. So our first target is going to be a .NET app. So there's a server component written in .NET. There's this nice GUI client written in .NET. And it's used for running, administrating, and by operators of physical access control systems and alarm systems. And it's made by RCO, RCO Security is a Swedish company. So I thought, for fun, I'd have a look at the security of their application, because it was nicely downloadable from their homepage, and it was like easy target to get into. So I picked on them, and .NET is kind of easy. There are good tools. It's kind of easy to get a view which is pretty much source identical using .peak or similar tools. So .peak is what I used. You can download it off of JetBrains. It's a free tool. And basically, it will unwrap your .NET application libraries and binary into something that looks like C# source code. So the application looks a bit like this. You have, when you start up the client, you get a login screen. First, it has to find the server. That can be a bit tricky in your lab setup, but yeah, first it has to find the server, and then you get a username and password prompt that you can try to log into the server. And like I said, it's a .NET app. It's written in C# probably. So what I did is I put the server first libraries into .peak, and I had a look, trying to find out, okay, what can I access on the server side? And it turned out that the server.NET components were actually just a thin layer that were proxying all the calls back to an old style COM object written in C++. And yeah, I wasn't going to go reversing that thing for fun. That's not really my idea of fun. So I went back and thought, well, you know, the client is all .NET and nice and new and shiny, so maybe I can find something there. So this is what it looks like in .peak. I don't know if you can read that in the back row, but basically you get a nice source view, and you can look around through the different files. There are DLL files called assemblies, which are basically libraries with code, and you can just look through everything. As I said, I didn't really get anywhere with the server because the server application wasn't actually written in .NET. They just put a nice new shiny layer of .NET on top of the old horrible C++ application. So I went to the client code instead and had a look at trying to find that login screen in the code. And it was quite easy. There was a log-on model view, something like that, with a nice function called let's see. This was a server-side code. Sorry. Let's go to the... Yeah, so basically, one day at SecT, I was bored with the CTF, and since the CTF was a lot of web stuff, I just, what if I just put SQL injection in this .NET app? And it actually worked. It logged me in. So then I really had to get into the client code and look what the hell is going on here. So this is the client code. And it has this nice function called logon, and you can kind of easily see what it's doing. It's taking some kind of a dialog, which is the password entry dialog box you saw there. And it's pulling out some values called password and username, and it's putting it into connections named connect. Functions named connect and log on and stuff like that. So I thought, yeah, this is kind of easy. If I could just take this code and put it into my own little program, calling the same functions, then I could actually do something with this SQL injection I found. Because it was kind of useless as it was in the username field, so you couldn't actually change which user it logged you in as, and the username field was like 20 characters maximum, so you couldn't really put a lot of code in there. So I thought, well, okay, let's make our own client to talk to the server. How hard can it be? And first thing you need is, of course, some kind of a development environment, so you can compile your own .NET code. Microsoft makes it really, really, really easy to start developing for Windows and start working with .NET. So you can actually download a fully built VM in whatever flavor, VMware, Hyper-V, VirtualBox, Parallels, which is a Windows 10 machine of the latest variety, updated with the latest Visual Studio 2017 and everything, subsystem for Linux installed with your nice bash shell you can get in. Everything is just served up for you. Only downside is it's 20 gigabyte download and it expires in 90 days. But the thing is, in 90 days, you'll have a new 20 gigabyte download with the newest version of Windows 10 and the newest stuff pre-installed. So it's actually quite a nice way of keeping up to date. So that's a good tip. You can download that. That's actually what I did. Small tip for you VMware users, if you chose the VMware flavor, is that you get a zip file with an OVF file and a VMDK, virtual disk image. Don't actually import that into VMware, because you'll end up with, it'll copy that disk image, and you'll end up with 3 copies of a 20 gigabyte disk image, and you'll run out of disk space and be angry and sad. So don't do it. There's actually a nice tool included with VMware called OVF tool. You can use that to import or unpack this OVF file into a new directory, so you get a new VM without actually doing anything with the hard drive. So you can manually move the disk image over, and it won't create this copy so that it takes up 50 gigabytes of your hard drive unnecessarily. So that's a nice tip. Has nothing to do with this, but it's a nice tip. So what do we do? Well, we start up the Visual Studio interface. As you can see, it looks kind of similar to .peak, but this is the Visual Studio interface. And you start a new project. There's a nice wizard. You click through that, and you get an empty project, which is just a main function basically with nothing in it. And you can start taking your code from .peak and just cut and pasting it into Visual Studio and trying to build up a program that kind of does the same thing as the client, that actually uses the same libraries as the client does, to connect to the server and perform the login function. So that looks something like this. You put in a number of using declarations in the code so that you don't have to write these long paths. And then similarly, you link in the libraries, the client libraries from the app that you want to use under references in the right-hand solution explorer view. And that just means that you can easily find these functions that and objects that you're trying to reuse from the client libraries. And then you can just use them. Simple as that. So if you go back to .peak, you find the login function. You can just take these connect and log on function calls, cut and paste those into Visual Studio. It looks kind of similar. And then you, of course, have to find where in the code in .peak, you have to find where are these objects coming from. How do I create those objects so I can call the methods on the right objects. So in this case, it was very easy to just, a little bit further up in that same source file. So you take that, paste it into Visual Studio, make it work, and just create, if you don't know what it does, like this, in this case there was a lot of logging stuff in an output window logger created to put into, that you had to put into the client objects. Just create one. If it doesn't work, then find out why it doesn't work and use your powers of deduction to find out what the error messages are telling you. But in this case, it was really, really easy just to get it working. So now we have a client that we created ourselves that can talk to the server. And the awesome part of this is we don't have to care about that binary protocol that's running between the client and the server. We don't have to put a proxy in there and try to break TLS or whatever they're using for security. Because we now can just talk to the server using the client code that we stole from the app. Okay, so another little quick tip. If you don't like Visual Studio, if you don't like to download 20 gigabytes of VMware image, then there's actually at this path in every Windows installation, as you see from the path that comes with the standard install of the .NET framework, there's actually a C# compiler ready to use. So basically, if you take your code in just one file, and you point this C# compiler at it, and then instead of those linking in those libraries in the Visual Studio view, like I showed you earlier, you just put them on the command line, /R, and then lib1, lib2, lib3, works equally well. And then you get a nice exe file that you can run. So if you're more into command line stuff, this is a quick way to get going. It's also a nice way if you're in a constrained environment, say you're compiling your code on somebody else's computer, then this is a nice way of updating it. So I thought I'd show you my little program that I made. Let's see if that works. Is it still showing on the screen? Yep. Is this text too small? You sure in the back? You can see? Okay, so I made a little demo program that just connects to the server and lets me log in with the default credentials just to show that it actually works. And fingers crossed. Yep, connects me to the service. I've got a nice little printout there of the service version, so I can see if they've updated or not. And then I can try to log in with just the default credentials. The default password is 1234. And then I can just use the app, right? So I used it to dump out the users. In this case, there's only the default user installed, and all the access cards with the PIN codes. In this case, it's just a default empty database, so you don't actually get any lines there. But trust me, if it was a real install, you'd get all of the card numbers with the PIN codes attached to each card number, which could be handy, I don't know. So it can be as easy as that to actually get into hacking an application that you don't actually know the protocol for on the network. But we of course want something better than just connecting to it and using default credentials, right? We had this nice SQL injection, so we want to make a better exploit. So we have a SQL injection. It's pre-authentication, so anybody who can connect to the service with a TCP port can use this bug. But of course we want command execution instead of the server, because why not? And the target uses Microsoft SQL Server as a database, so that's where we're ending up with our SQL injection string. And SQL Server has this nice, XP command shell function that, basically takes whatever string you want and sends it off to cmd.exe and runs it as a command line. But of course, nowadays, people have figured out that that's maybe not a good function to have available to hackers like me, so it's disabled by default in SQL Server versions going back like 5 to 10 years, I don't know. So nowadays, you can't really use it. Except if your app server is stupid enough to access the database as the database administrator. So it has privileges to actually re-enable XP command shell functionality. And then it's really easy. Then you just have to send in one string that, into your SQL injection that re-enables XP command shell, and then another one that actually runs the command. So thank you very much, RCO, for running your application as the SA user in the database. That made it kind of easy, except for SQL errors, which is always a pain to debug. Why isn't XP command shell working So I had to find the log file for the server component. And that, gives you some indication of errors, as you can see here, probably. But if you also find the configuration file, and find in the configuration file the log level, you can actually up that to debug and get much more information. It will actually show you what string it's sending to the database and show you the database errors coming back. So that was pretty much, I needed that to get this thing working. Also a good tip to, if you're hacking on an application, go try to find out where the developers put in the debug functionality and turn that on, because it's going to help you. It's going to help you understand what's going on. Yeah, so let's have a quick demo of what that looks like. Let's see if we can swap over to the screen again. You can still see? Yeah? Okay, so in this case, I'm going to try to use XP command shell in the database to start me up a PowerShell instance that will connect back to my computer, so I get a nice interactive PowerShell interface to play with to hack the system. So I have to find out what my IP address is first. And then I'll put that in there as a parameter. And then I'll run the updated thing. As you can see, it's connecting to the server. Oh, that's not a good idea. Yeah, and I get a connect back from the server to my IP address. And I can, for example, type, who am I? And I see I'm the database instance. And I can, look at whatever's in here and see just, which host I'm on and whatever. So this is actually PowerShell running on the server, right? So now we have our nice command execution on the server that's running the physical access control system. So that's kind of fun. Let's go back to the presentation. Okay, so what can we do now? We've got interactive PowerShell running on the server. That's fine if we want to go hacking other systems, for example. If you saw the initial code I showed you, the first demo, I logged in with default credentials. With the SQL injection, I can of course add a new user as well to the database with a password that I know, so I can just add a backdoor user that's also an admin and start playing with physical access control system. But there's other stuff you can do as well. It's a physical access control system, so you could start randomly opening doors to see what happens. It's just one more of these function invocations on the same object that you've already created in your client. That might be fun. Or you could try to log in with a really, really long username. That's left as an exercise for you guys to find out what happens if you do that. But I found this nice bug, it's pre-authentication, so you guys are probably all thinking, well, it's a physical access control system. That computer is going to be locked away somewhere in the cupboard, and it's not going to be on any network that you can get to, so what's the big harm, really, right? It's not like it's going to be connected to the internet. Or is it? So a couple of my colleagues have written this tool called Hibiki, and Hibiki is basically, you can think of it something like your own private showdown in your back pocket. So it's an internet-wide scanner that gives you results nicely searchable in a database. And the interface looks something like this. As you can see up there top, you can search for okay, so give me every result from port 23, which is telnet, which has the keyword nuclear somewhere. And then you can actually find some interesting stuff on the internet. But I wanted to actually have a look at this application that I found a bug in, to see what's the actual exposure on the internet. How many people are running this vulnerable application and actually exposing it to the internet. So instead of port 23, I kicked off a custom scan at port 8090, which was the default port this RCO system was running on, and sent it a bit of information that would provoke a response, so I could see if it's actually responding or if it's a web server on port 8090. I'm not really interested, right? So that's the second query command there. And as you can see, there's quite a lot of hits, and this is just people running .NET stuff on port 8090. But we can see 17 hits from Sweden. So we click on that, adds a new search term, and you can see these nice nicely printed out. You can see which ISP it's running on, and actually all of these turned out to be this product, exposed to the internet with this pre-authentication bug in it. Mostly it was Swedish condominiums, bostadsrättsföreningar, so not really a high-value target, just getting into somebody's building is not really a big deal in Sweden because we have nice beefy doors on our apartments. Actually, so this morning I reflected, sitting on the toilet, that the door to the bathroom at the hotel here is probably beefier than most apartment front doors that you find in Europe. So yeah, my apartment door is like steel, and it's got bolts running through both. Yeah. So getting into somebody's house, an apartment complex in Sweden, doesn't actually give you much if you're not looking for a place to sleep or something like that. So it was an interesting exercise. It was interesting to actually be able to find what impact it had on finding these things exposed to the internet. There was one interesting finding that you can come ask me later which company that was, because I won't say it on the live stream, but I might tell you if you ask later. So 17 hits, and basically all of them I could have. We also have to talk about the vendor response, right? So that's an important thing, is how did RCO Security take this when I tapped them on the shoulder saying, you guys need to look at this? They were very, very quick to respond. I actually sent them an email, asked, how do you guys want this information? It's about a bug in your system. They said, okay, fine, you log into the support portal. Here's a username and password that you can use. And then the guy called me up on the phone and asked more questions, and basically within a week they had patches out on their website for people to download and install. And they actually fixed the SQL injection issue correctly, which is, that's quite impressive for a company that hasn't worked with security much in the digital domain. These guys are physical security guys. So they actually fixed it by using parameterized queries instead of cut and pasting SQL strings around, which is the correct fix. And it was a pleasure to work with them, actually. They were really nice and responsive, and they weren't angry at all that I had found bugs in their system or whatever. Unfortunately, getting the customers to actually patch their systems is going to be hard. RCO Security is one of these people who make equipment. They don't actually sell it to the bostadsrättsförening or the company who's using it to protect their offices, for example. They sell it to an alarm installing company or a locksmith company, and they actually have the contacts with the end user. So that means there's another step in the chain, which means it's harder to get information out to the actual end users that, updating your software might be a good idea. So some people are still running like 5-year-old or even older versions of their physical access control software. And this goes for all vendors of that type of application. Basically, because nobody thinks about that computer in that cupboard, and that maybe we should have somebody look at patches for that machine as well. So that's that's the downside. But hopefully people are going to update and fix this vulnerability. If not, you can have some fun with it, perhaps. Any questions about that? Because now we're going on to Java instead. Any questions about .NET stuff, or should we take it at the end, perhaps? Yeah, we can take questions at the end as well. So, at the beginning, I talked about hacking client-server stuff where there's a weird binary protocol in the middle and you're not really sure about how to go about doing that. And of course, Java is very prevalent still in enterprise software. This target that we're going after, I'm sorry, I can't really tell you what product it is because they haven't really fixed it yet. So yeah, maybe if you get a hold of me later, but I'll show it to you in the slides. Basically, for Java, it's exactly the same thing as with .NET. There are great tools available that will take your Java application, your jars, which are basically zip files with Java classes in them, and take those classes and decompile them into something that looks very, very similar to Java source code. So the one I used, which is the one that out of the ones I tested was the one that gave the best results or looked the best or whatever, was JD GUI. You can find it on GitHub, it's open source application even. And it looks something like this. So you take your jar file, you point JD GUI, open the jar file please, and show me everything. And you get this nice tree view, just as in .peak with all the classes, and you can start navigating the application just as if you were in an integrated development environment and browsing through the source code, basically. So wise from the last time, this time I actually didn't start by looking at the server-side code. I went straight for the client-side code and said, okay, let's find that login function, because that worked really well last time. And it's quite easy. There's a class called AC Server Connection, which sounded interesting, and in that there's this function that takes an INET address, a port number, a username, and a password as parameters. So it was quite easy to find out that that's probably the thing that's connecting to the server and logging in, right? And then you can see it's using an HTTP connector to connect to the server. I'd actually figured out already that it did that because the traffic between the client and server, sniffing that, it actually looks like HTTP. The problem is that it's doing just the one query, and then everything after that is a binary protocol. So it's just faking being HTTP, and then actually just running some weird internal protocol over the socket connection. And you can see this in the source code. It uses the HTTP connector class to connect to the INET address and port. And then the first thing it does is it takes that thing and it gets an output stream and an input stream from the HTTP connection, and then it uses that to communicate with the server. So yeah, exactly there. You can see it's connecting to some URI on the server, applying the username and password, which gets passed as a basic authentication string in the HTTP request. So that's actually what happens first, is that the web server on the server side, which is a Jetty, verifies the username and password and decides to let you in or not, and then after that, it's just talking something other than HTTP, right? So some weird protocol that we don't understand, but we know how to repurpose client code to actually talk to the server, so we're going to do that in Java instead. So, looking a bit further along in the function, after it connects, and it brings out this input stream and output stream, it starts using the object input, object output streams to write and read Java objects between the client and server. So basically this is your classic example of a Java deserialization vulnerability, where the server and the client are communicating by taking a Java object and then packing it into some binary stream, sending it over the network, and then reconstructing the Java object on the other side. So that's how they're communicating. They're taking like an object that represents a command, for example, and they're streaming that over the network, reconstructing the Java object on the server side to figure out, okay, what command has the client sent me. So we can send objects from the client to the server, and the server will take anything that we send on the network, and it will try to make a Java object out of that. Basically, a Java object of any class that the server can instantiate, it will do that for us, just because it's so nice. So there are super easy tools, actually, to use this for evil purposes. One good example is the YSO serial library, which creates, weirdly assembled Java objects that do things like command execution, for example, or some other nice functionality that you might want. So we just need to find a way to deliver one of those YSO serial payloads to the server. We just need to find a way to log into the server using that HTTP-alike thing, and then send over a serialized object created by YSO serial that will give us a command channel, right? How hard can it be? So, first step, of course, is that we have to set up our Java development environment to start writing our own client and repurposing the client libraries once again. So this time I'm not going to download a big VMware image. This is how I always start my Java projects. I Google Java Hello World, and then I take that example and paste it into a text file. That's how I start. Because why fuck about with installing, Eclipse or whatever Java application development studio thing when there's actually command line tools. If you just download the OpenJDK package from Oracle, you install that, you'll find a nice Java compiler. And it's actually just as easy or even easier than the .NET example. You just point the Java compiler to your Java code, and it will compile that thing, and it will find everything that you referenced in there and find magically where those things are, for example, in default libraries or in other files on disk, and just compile everything and package it up nicely in a jar file for you. It's really, really easy. And the same thing goes for Java as with .NET, that you just have to point it to where your client libraries are, where the objects are that you want to reuse from the app, that you've stolen from the app to connect to the server. In this case, it was a bit trickier. So this is what it looks like. I get my Hello World example, which gives me a text file with a main function that has a print Hello World statement in it, and I modify it a bit. So first of all, you have to make sure that the class name containing the main function is named the same thing as the Java file it's in. If you don't know about that, it can take you like half a day to figure that out. And then you import your Java libraries. So YSubSerial, you just import that, you put it into a directory named YSubSerial in the same directory as your code that you're writing, and it'll just automatically find the files when it's compiling it. And all the Java libraries from the default libraries from the Java package, you can just import all of those dependencies as well. Nice trick is to just import .star, and it will just bring in everything, so you don't have to start figuring out what the client libraries are actually using in the Java framework and importing everything manually. That just takes forever. Just import .star, and the compiler will do all the heavy lifting for you. But it was a bit more difficult, like I said. So in my case, I actually wanted to modify one of these classes that I was reusing from the client library. It actually had some client-side checks. Not really security checks, but it was checking for matching versions of the client and server and not letting you log in if you were running a too old client. And I didn't want that. I wanted my tool to be able to connect to any old version of this software and exploit it. So I wanted to reuse this class, but with some modifications. So that's actually not too hard. Since we have our decompiled Java application, we can just copy and paste basically a whole class definition into a separate file, and then change that. So in this case, I was working with a directory called test. So my code was in a directory called test, and the Java compiler knows that because I've given it a package statement saying that my stuff is all in this directory called test. So what I did was just take one of the classes, which was called AC connection. That's where I wanted to make my modifications. I just took the contents of that, copy and pasted it into a new text file under my test directory with the same name as the class I wanted to modify. And then I'll just use that class instead of the class in the client libraries to connect to the server. So this is part of that code, and you can then see that I put it in test/acconnection.java file, and then I started commenting out the stuff that I didn't need from that class. And then we're basically there. We can create our AC connection, which is our AC connection, the modified one, not the one in the client libraries. And the hardest thing actually about that was figuring out how to connect to the server without doing the certificate checks for HTTPS. That was actually the hardest part of it, finding a way to replace that class that did the certificate checks with something that accepted any old certificate. Again, I wanted this exploit to be able to connect to any server, and damn the consequences. And then, after we connect to the server, we just create one of these YSubSerial payloads, and we use exactly the same code that we cut and paste from the client, which writes first an integer 1, and then an integer 1, and then some old Java object. right? That's exactly replicating what the original client was doing when it was logging in and starting to use this binary protocol to communicate to the server. Just this time, we're writing an object which is not one of those client-to-server commands, it's actually a YSO serial payload. So, create our payload class, we get from the argument string to the main function the command line that we want to run on the server, we put that into the YSO serial payload, and then we just write it off to the socket to send it to the server, and I'll show you what that looks like. If I can. Yeah, there we go. So, again, I need to make sure that I have my IP address, and yeah, I can probably do this just to show you. So this file is exactly what I showed you in the slides. And this is what I'm running right now, demo 3. So now it's connecting up to the server, giving it the username and password, and then writing the YSO serial payload. And hopefully it'll do something after that. Takes a while because my machine is slow. And we get a connect back again. So this is exactly the same payload as I used in the previous example, which is just an interactive PowerShell that I can communicate with. So who am I? This time I'm system, host name, it's the same host name, and start exploring the contents of that computer environment. And thank you. So, what actually happened here? Breaking it down. We actually pretty easily found some severe vulnerabilities in these applications, just because the simple fact that the code is decompiled. It's actually pretty easy to open the lid and look what's happening in the application. So if you have any kind of development experience, you feel right at home analyzing these applications to find out how they work. And we can find and exploit these bugs without actually understanding the network protocol. We just need to figure out what the client code is doing, and then we can do the same thing, potentially by reusing large parts of that client code base. And all we needed basically was the client code base. We didn't need access to the server to find, for example, this deserialization vulnerability and exploit it. We didn't even have to look at the server code. That could be a black box to us. So say we have an example where somebody lets you download the client software off the web, but the server stuff is closed source, behind locked doors, nobody knows how the server works. You can actually still find vulnerabilities and exploit them in that scenario just by analyzing the client code. So what did we learn? What did we learn here today? Well, we shouldn't be scared of these fat client applications. Just because it's not a nice HTTP REST interface doesn't mean it's going to be hard to understand how it works, enough that we can see if it's secure or not. And reading .NET or Java code isn't really that hard, especially because developers, they name things usually in a sensible way, so you can just find the login function, it's probably going to be called login. You can basically search for what you're looking for. Don't get put off by these huge IDE installs and downloading 20 gigabytes of data or installing Eclipse and all that stuff. Actually, with a few command line tricks, you can very, very easily get it up and running with a .NET or a Java exploit. And always start looking for that login function because that's where the juicy stuff is going to be happening. That's your, that's security code right there when there's a login happening. And finding the debugging features of the application is going to help you understand what's going wrong when you're writing your exploit. So that's a really good tip. So reusing code from apps, fat clients, is easy, and it helps you find and exploit bugs. Not just in the login function. If you just manage to log in, you have lots of juicy application attack surface there to explore. So in the case of the physical access control system, for example, I could just start looking at, okay, what functionality do they provide? Oh, they provide handy functionality to show and edit all the cards and PIN numbers. Nice. Or open doors or whatever. So you can always find logic vulnerabilities and other things in the application just by being able to talk to it in a way that isn't clicking in the GUI. So hopefully you did learn something, and I'll also hope that you have some questions for me. Any questions? Thank you. I think Johan is going to run around with the microphone if anybody has questions. Otherwise, if you want to ask about those things that I couldn't show on stage, you can find me later on. I'm going to be here all day. So just come and talk to me if this sounded interesting and you want to talk more about that. Thank you.
So I think there's a question here.
Okay, so Hugo has a question.
How's it working with the Java people? Were they as good as the first people, and it's just anything, or?
You know, I sent the information to them in pretty much the same way. Figured out, you know, the support contact, and the guy said, "Yeah, great, I'll forward this to the R&D department, and they'll have a look at it immediately." And then, like a month later, I pinged him and went, "You know that thing I sent you? How's it going?" And he was like, "Yeah, they looked at it already. We don't know if it's going to make it into the next release, though. Maybe the release after that. We'll see." So it's not really patched yet in a way that's reproducible, so I can't talk about exactly what company or what product it is. I did actually accidentally show it, so if you rewind live stream, you might actually see it in the code. But yeah. So yeah, they were nice and all, but you know they weren't as quick.
Any more questions?
Any
Over here?
questions? One more. Great.
The other side, you have these easy decompilable languages like C# and Java. Is there anything the developers can do except writing secure code?
Yeah, I was just going to say that. Maybe not create so many vulnerabilities. That's one thing. It is really hard to hide how software works, because if it's software that somebody else has to run for you, so in this case, if it's something that you sell to your customer and the customer has to run, then you're never going to be able to hide what it does. You can make it harder. For example, the first guys made it harder for me just by using C++ and ancient programming techniques and com objects, and I just went, I'm not going to spend 20 days working on that. This is just for fun. So you can make it harder for people to reverse engineer, but you're never going to be able to hide how it works. On the other hand, the SaaS model of actually just providing a service to your customer and not actually letting them run the software, you run the software yourself, then you're in a much better position to actually hide how the software is working and also hide the flaws a bit, which is good for you maybe, but it might be bad for the customer, because the customer might find it harder to verify that the code that's handling their data is secure. So that actually happened to me last week, that we had a customer who was just going to start working with the SaaS vendor, and they just figured out like a week before they went live with the SaaS vendor, oh, maybe we should check security. So they came to us. And the SaaS vendor was very, very, not very, but they were a bit cocky about it. They said, oh, we partner with so-and-so, and we're a Salesforce official partner, and they've done audits on our stuff before, so you won't find anything. And of course, we could quite easily show that they had loads of vulnerabilities because they never done a real security check of their application before. And the message that I give to my customer is not, okay, these guys have these horrible vulnerabilities, you shouldn't use them. That's not the message at all that I want to send. The message I want to send is, maybe you should ask questions about the SaaS vendor. How will they make sure that these vulnerabilities don't pop up in the future? Because it's all nice and good that you have agile development methods that let you release code twice every day to your SaaS platform. If you don't have a good process that makes sure that the code that you deploy into production is secure, and you have to do that in the development process, then your customers won't actually know what application is handling their data in a week's time or a month's time, because you've changed the code already. So doing audits like the spot check, the one-time check, is not going to work in that model. You have to find a way to gain confidence in the SaaS vendor. Sorry, I went off on a tangent there, but it's fun to talk about these things. So I think my time is up. Thank you very much.
Thank you.
Any other questions? Just come see me later.